That's sort of the base times the height of the triangle. Triangle. And then the extended amount is the 2x.
Got it.
Is that okay?
Yeah.
All right. So then you do have to multiply in everything here. So it's really 4x plus 4 times 2x squared. And then you continue multiplying in. So you get 8x cubed plus 8x squared. And this equals 200. So now in terms of solving this, your very most commonly used option can be the calculator. Is that what you guys are doing in class?
Yeah, I think so, yeah.
Okay, so there's a couple of ways to put this in the calculator. One is to put this into y1 and this into y2, and then to see like, where they hit.
Yeah.
That's probably the best approach. Some students move the number over and find the 0. I think this would be a better option. Um, Let me just check that this has a solution first before maybe you graph it. X squared. Okay, so this does in fact have a solution.
So let me think.
Let me know if you have any questions about how to graph it or solve it. The graph is actually a little bit different than what I put here. It actually just comes up and hits like that.
All right, I'm back. I just had to charge my calculator a bit. This having battery.
Okay, well, so the solution here, when you graph it, is 2.626. And that's the X value. So sometimes you got to be careful here because they're asking you for what are they asking you for? They ask you for the dimensions. So that's just the height. Like you almost have to say, okay, the height is X, the width is 2X, and the length is 8X plus 8. And then you got to put this number into the equation for each of them. Is that okay?
Yeah, let me just put it.
Should we move on or more
Uh,
questions on this?
let's see, I'm still getting wait, all right, yeah, we can move on now. I got 2.626 feet by 5.252 feet by 29.008 feet. So 5.252 for the width, and then 2.626 for the height, and 29.008 for the length.
But, okay, you ready to look at the next one?
Yeah,
All right, the teacher's got a thing for llamas. Is that normal? All right, his square patio is to be made from 256 cubic feet of concrete. The thickness of the floor is 8.5 feet less than each side length of the patio. What are the dimensions of the patio floor? Okay. So here's the thickness of it. And it's a square. So this is X and this is X. And then the thickness of the floor is X minus 8.5. Is that okay?
yeah,
The drawing is really the hardest part, in my opinion. Is that okay?
yeah,
So the volume here is length times width times height. So it's that X minus 8.5 times X. And we know that that is 256. So this is X squared. So you're going to distribute that in. You end up getting 256 equals X cubed minus 8.5 X squared. And so you have to solve for X in this one. So graphing it again, and the order doesn't matter. You can put the number as y1 and the equation as y2. That's okay.
all right. So, equals,
This isn't working.
Yeah.
I need to reread this question. Do teachers using non-standard questions, which are weird, first of all, because there's like a million, so many of these on the internet. Um, Square patio floor, 250 feet of concrete. Thickness of the floor is 8.5 feet less than each side length of the patio. Yeah. Uh, this is weird. You have any ideas here?
Let me look back at the note. I think we might have done. Thickness of the floor.
There's kind of a scenario where I could see it being 4x, which does work. I think that's what your teacher meant. It's not written correctly. So if I change this to 4x, so each side length, so there's 4 side lengths, so that's the 4x less the 8.5.
Oh, each side of the length of the patio. So each, yeah, that would got it. Yeah, I think that was just a
I,
little bit unclear then.
I would ask, um, make sure that this is what was the intention. So it does become this, and this does produce a solution. Will you look for the x value,
Let
please?
me put it back into the calculator.
I think what the teacher could have used here is the word perimeter. Uh, but that's her discretion.
Okay, second first. And so we're trying to find where the y line intersects with the graph.
Yeah. So your graph, you'll see the graph kind of looks like this.
All right, I got it. Is it so this I got 4.848
Yes.
comma 2.6. So basically x equals 4.848. Then so
So that if we go back to what the question is asked for, and I know you got to do your whole chart thing. I mean, okay, that's fine. It wants the dimensions of the patio floor. To me, that means just the base, the two lengths, but she probably also means the thickness. I mean, although we don't talk about the thickness of our patio floor very often.
yeah, all right. So then that means that the length and the width are both 4.848 because they're both x. So length equal to 4.848 width 4.848, and then height is 4x plus 4x minus four and 4.848. So that means that the height,
Okay. Questions on
the
that?
height is 10.892.
And it's a weird thickness. That's a lot of con. These are weird problems. mean, the thickness of the concrete under your home is probably at most like 12 inches.
It's probably because I rounded off a little bit of the other two, but to the three decimal places. All right. Countdown. So now moving on to number three.
Llama has a toy that's in the shape of rectangular pyramids. So the pyramids are the toughest. I feel like the toughest to draw here.
Isn't it
There's
part
a
of like a square, but then you just draw like the three things up?
it's rectangular though.
Yeah, you draw it kind of like it's a parallelogram almost to look like a
Yeah, that actually is the
rectangle,
better. Yeah, that's the better way of drawing it. You're right.
and then you
Um,
just draw triangles kind of inward, I guess. But,
yeah.
all right.
All right. So the length, the width is two. The height is two more than length. So we'll call the length x. It's typically the longest dimension. And then the width
Height
here
is
is six less than the length.
width is six less than I think the six minus L. And the height is two more than the length, so two plus that. Find the width. The volume is six
So
feet,
this
so
one's
50 feet.
it's 1/3 the area of the base times the height. 1/3 times x minus 6 times x plus 2.
Right. Width is this one, height is volume equals 1/3. 1/3 base times height.
Now, here's the thing though, if you're graphing this, you don't have to expand it. Your calculator can handle this
Yeah.
like this. Now, um, what's weird to me here, okay, there's the 64. And a lot of students don't like that. They want to actually multiply this out, but you don't have to. You can put all that into y1 and then y2. Did your teacher
Yeah, I
say
think
that you
that's what
had?
she did in class during the notes. She just put it into like, the calculator like that and then put the
Okay.
y equals 64 as y2 and just so, dropped it like that. Um,
Oops. Let's see here. Does this actually work? Oh, it does. Yes. This one actually does
Let me
intersect.
put it into the calculator. 1/3 x and x minus 6 So x equals 8.264.
8.264.
Yeah, with the rounding.
Yes, that's good. Okay, so then you got to go back and decide, well, is that what they're looking for? And they want the width. So
If
I
it's
should
the
have
width
labeled like
would
width,
be, you have to find
length.
the length. Yeah, but length is already found. So width is 6 minus 8.264. Wait, oh wait, wouldn't it be 8.264 minus the less than minus. Yeah, I just made a small mistake in writing down it at the beginning. So minus 6 times 8.264 minus 6 is 2.264. That's the width.
Exactly.
The,
Yep.
the
And
width.
then make sure you use the right units. I actually have not emphasized that at all here.
Yes,
So
in this
width is
case,
in
it'd
feet.
be feet. Yeah. Or,
It's really
yeah,
it's
feet.
really easy to miss that, and that's a big part of this.
Yeah. You kind of emphasize that in class. But yeah. Uh, all right. So that's all from the homework. Let me. I think there was a couple in yesterday's homework I
Okay,
didn't quite understand, so let me pull that up
sounds
now.
good.
I believe it was, yeah, these three. So let me just download this. So yeah, here's the entire thing. But the part that I wanted to ask is for parts G, H, and I part of it. So let me upload it now. It's part of the like number one of it, but let me upload it. See. There it is. All right. So yeah, G, H, and I have number one. That those three parts of number one is what I wanted to ask about.
Okay, yeah, I'm just getting it open here. So unfortunately, I mean to do this, I got to go back a little bit to the beginning to find the equation, um, the open box problem.
Yeah.
Yeah, open box most of the time for me means that it's like pre-owned or somebody opened the actual box. They don't mean that here at all. But there's they're saying we're gonna make a box here by cutting out squares from the corners,
Got
and
it.
that's x and so on. So this side is now 13 minus 2x, and this side is 8 minus 2x. Is that what you have from before?
Mm, fill it out first. Um, uh, yeah, oh, yeah, that's what that is what I have. Yeah, 13
Right.
minus 2x and
Yeah.
8 minus 2x. Yeah.
And so the volume is these dimensions times x.
Uh, yeah. Mm, Yep, that's what I
All right. So now you said G, H, and I.
Actually, F as well, because I think that's one of the ones
Oh yeah,
they
yeah,
got
yeah.
wrong.
So to answer these, you've got to graph this again, and you're looking for what's going to happen here is the graph's going to do something, but it's going to hit a peak, and that's what you're looking for.
I
It
think
it
this
may it may
case,
come down and go back up, but you're looking for
yeah.
and your teacher should have talked about domain. Your domain in this problem is 0 to 4. I don't know if you actually had to find that.
Um, yeah, I think all she asked over here was if it was where it was increasing, where it was decreasing, but yeah, she did explain that on the top there that it had to be between the reasonable domain, which was on number B, which pretty much, I guess, said an easy way to find or easy way to find out was to take half of like the shorter side of the object. Like if it was, for example, this box, you take the 8 centimeters and divide it by two, and you would get the reasonable domain.
Exactly right. You can't fold it over itself.
Yeah. So yeah, I did get 0, 4 for the domain.
So go ahead and graph this and tell me where this max at the x value.
Um, oh, let me put it back. I want to kind of should wrote down. No, should have.
And the y. I want both ordered pairs or values up here.
Okay, so for x cubed and x cubed. Oh wait, I should have it here. 1.61 then comma 475.26.
Okay, very good. So the x is the x. It's the actual like cutout piece. The 75.27 is the volume. That's what's on the y-axis. So depending on what it's asking, and that's where you said F part F here. Part F is the maximum volume is 75.27 uh, units. Let's see, centimeters cubed.
Got it. So you take the y value of the maximum, and
Yes,
that is your maximum volume,
most of the time, yeah, that's right. Um, Full sentence. Uh, just be careful
the
to give them what
maximum
they
volume
want.
is like that. Yeah,
Yes, just repeat the words that they use. That's what your teacher wants.
got it. So something like the maximum volume
Yeah.
is
Yes.
75.27 centimeters cubed. Got it.
So the x we just found 1.61 centimeters. I guess you don't need a sentence here. Oh, it is. It does say sentence 6. All right. This is unbelievable. Uh, So again, the squares, that should be removed, have a length of 1.61 centimeters.
Got it. I think that's the same thing that I got. But
And then the dimensions, you have to put that X value back into both the length and the width. And then you'll have your three dimensions. I guess you'll need a sentence again for that.
uh, got it. I think I got the. Yeah, I think I got the same
Great.
dimensions. Yeah. Then yeah, I was the last one I had a question. I had questions on because yeah, some
The only thing
particular
that
part was
changes for
missing.
part I is that instead of you finding the max, you set it equal to 66. Yeah. So let me grab the snip of that. So this time your graph will actually hit at 66 in two spots. That's why the instructor is saying square or squares.
Got it. So the intersection space. Okay.
There's two intersection points. So you want to graph that.
Got it.
Ends up being 1 and 2.89.
Got it. Yeah, that makes it a little bit more clear because I was kind of confused what she was asking for there. Got it. I think I get that problem now though.
Yeah, what else would you like us to look at today?
We do have like a a shorter quiz on block day, like a warm-up quiz that she usually gives, which is a lot shorter. But I'm pretty sure it's going to be on like 4.10, 11, 12, and maybe like 13, the 2 days of 4.13. Um, so I think maybe more practice. Maybe we could do a problem like we did today, like one
Okay.
from four. Yeah, it could probably.
Let's see here. All right. Yeah, let me see. I mean, the so the one I was doing with a student today is it's an open box again, square base, and then the yeah the height of the box you might find is like 2x, and the volume ended up being pretty large. I don't know, I'll just say 1,000, but this is it's kind of the same as all the other problems we're doing. You have to set up the equation, graph it, and then figure out what it's asking for.
Yeah,
There are other variations on these problems though. Did you do anything with surface area?
I don't think so yet.
Okay. So this one, the volume is x times 2x. So 1,000 equals 2x cubed. And then you graph and you find where they intersect. They're all sort of the same. You just have to set them up. Might be good to think about some of the formulas. So like a cylinder, 1/3 pi r squared h. I mean, why would you use that? I don't know. But you did pyramid. Pyramid was the 1/3, the area of the base times the height. Seems to be emphasizing the geometry formulas, the prism,
Yeah,
the area of the base times the height. Cone. Sorry, no, this is not a cone. That's not a cylinder. That's the cone. The cone is the 1/3 pi r squared h. That would be an example of a problem. Like, let's say they gave you a cone and they told you that like the radius was the 2 times the height less 5 maybe. And so when you're putting it into the formula, you have to square it, and then you would actually want to put this into the calculator, and you might find that the volume is like, 200 or something centimeters cubed, something like that.
got it.
So it might be worth looking at your geometric formulas or formulas from geometry, or actually, I think I still have this reference sheet up. I haven't used it in forever for volumes. Nope, I guess it's gone. Okay, nope, there it is. We dropped this in the chat. That might be worth like printing out, looking at some of those formulas just to make sure you got them. All right, we're going to stop there for today.